The electron structure, it's a very tedious thing to do. To constantly draw the shells, the nucleus, the electrons would take a long time just for me to explain what is going on to an electron for a particular atom, for example. And so chemists have constructed a shortcut mechanism in expressing how the electrons are structured around the atom using a concept called electron configuration. Now, this term can also be interchangeably used as electronic configuration. But that's not the important thing. The important thing is to be able to write the notation that is associated for each of the structures. And so, each electron structure will have a particular electron, each atom will have a particular electron structure. And for each structure, we have a particular way of writing the electron configuration, which is a shortcut way, again, to understand how the electrons are structured without drawing it out physically. So let's take a look at hydrogen. Hydrogen has one electron. And so when we express the electron configuration, we usually would like to have parentheses. Brits here call it brackets, which I don't understand why, but there you go. That's your parentheses or brackets. And in that bracket, you have only one shell. So you don't put in any other extra notations to it. And how many electrons are there on that one shell? One. So you write one down there like so. And that is the electron configuration for hydrogen. Let's look at helium now. Helium has one energy level and it has two electrons. So you don't put in any extra notations and you just say that it has, the shell is in this little bracket here, or parentheses, and you have two electrons in that bracket. Fine, everything is great. Now let's talk about lithium. Lithium has 3 electrons, 2 on the first energy level and 1 on the second energy level. Now, to draw the electron configuration, you first need to split, have a symbol to indicate. You need to put in a symbol to indicate that there are 2 energy levels here. And the common way of doing it is to put a dot to split the 2 energy levels. This will be the first energy level, and this will be the second energy level. The first energy level has 2 electrons, so you write 2 in here like on the left side like so. And on the third electron, on the second shell, you have 1 electron and you write it in like so. For beryllium, you have 2 electrons, two shells, so you split them up like this. So this will be the first shell, this will be the second shell. 2 electrons on the first shell, and 2 electrons again on the second shell. Let's look at boron. Boron has 2 energy levels, so you again split it up by this notation here. And if you look at boron, it should have 2 electrons on the first shell and 3 electrons on the second shell. Carbon will have a 2,4. Nitrogen will have a 2,5. Am I going too quick? Let's look at oxygen. It has 2 energy levels, put a dot in the middle, 2 electrons on the first energy level, and 6 electrons on that second energy level. So you have it like so. Fluorine will have 2 energy levels, 2 electrons on the first energy level, and 7 electrons on the second energy level. And finally, neon will have 2 electrons on the first energy level and 8 electrons on the second energy level. Now, let's talk about another element. I'm not going to draw down the electron structure anymore because this just takes too much time. Yes, chemists are lazy. Sodium, if you look at the periodic table, is on the third shell, third period, so you have 2 dots, 2 electrons on the first energy level. It has a full second shell, and then finally it has 1 electron on the outside shell. Magnesium will look almost like sodium, but, okay, I don't know what happened there, but it has 2 electrons on the outside shell. Aluminum will have a 2, 8, 3. Silicon will have 2, 8, 4. Phosphorus a 2, 8, 5. Sulfur a 2, 8, 6. Chlorine a 2, 8, 7. Argon will have 2, 8, 8. Now, let's go back up and talk about potassium and calcium. So potassium will have an electron configuration of 2, 8, 8, 1, and calcium will have an electron configuration of 2, 8, 8, 2. That's it for electron configuration for atoms.